Look at question number 8. Let me tell you, this is again one of the most important questions. It's a textbook question, chapter solved example question, previous repeated question, repeated forum paper question, entrance examination question. This is very, very, very important, slightly complicated as well. But don't worry, we will do it. Whatever time it takes, we will do it again and again till all of you get it. It's supposed to be one of the most important questions in class 12. Okay, it's a textbook one. And if you have seen this in school, the chapter is finished in school, you must have seen this in school. Have you seen this question in school? Question number 8? Yep, that's very important. Let's read the question. The electric field components are Ex is equal to alpha x raised to half, Ey is equal to 0, Ez is equal to 0, in which alpha is equal to 800 Newton per Coulomb. Okay, electric field components are Ex is equal to alpha x raised to half. So what are the electric field components? I'm writing them here. Okay, Ex is equal to alpha x raised to half. Okay, alpha x raised to half. Ey is equal to Ez is equal to 0. What does it mean? The electric field is purely confined to x-axis. There is no field along y-axis. There is no field along z-axis either. Did you understand the meaning of the statement? Yep. Okay. So read it again. The electric field components. Electric field can have components in different directions. Ex can be there. Ey can be there. Even Ez can be there. Right? Electric field can be along x, y, z axis. And Ex is equal to how much? Alpha x raised to half. Ey is equal to 0. Ez is equal to 0, where alpha is 800. Alpha value is given. Alpha value is 800. Okay. Forget about the unit. Calculate the flux through the cube, the charge within the cube. Calculate, you have to calculate. There are two questions. We will see one by one. Calculate the flux through the cube and assume that one side is 0.1. I'll do this question. Assume that one side is 0.1. See this? I'm going to draw the figure. So x-axis, y-axis, z-axis. Okay. And I got a cube situated here. This is the cube. Okay. All right. We have the cube here. See this? Draw the figure, please. Let us do it together. Right. This is one side of the cube is 0.1, and even this distance is 0.1. Okay. That is given in the text. Given in the question paper. Draw the figure. I'll tell you how to do this. Tell me when you're finished drawing this. Everyone, I might check in the end. Okay. You have to draw this. All right. So this is the question. This is x-axis. This one is y-axis. And the one which is coming out of the board is z-axis. Actually, this axis is coming out of the board. This is how it looks. This is how it looks like. Understood? Z-axis is coming out of the board. X-axis is to the right. X-axis is to the right. Y-axis is straight up. Z-axis is actually coming out of the board. But I can't draw it out of the board. That is why I'm drawing it in this direction. Anyway, I've just placed a cube over here. Where is the cube? The cube is located at a distance 0.1. Okay, cube is located at a distance where? It is given in the question. The left surface of the cube is at 0.1. One side of the cube is also 0.1. Okay, so let us come back to that. Okay, so I'm going to write the flux now. What is the equation for flux? I'm writing flux here. So how many surfaces are there? Look at this. Look at this. This is the surface. This is the cube. Just imagine this is the cube. Okay, I have a cube like this. Okay, and the field line is going from left to right. Field line is going from left to right. All right. Just imagine a field line is going in this direction, left to right. Okay, left to right. Field line is from left to right. And I take this surface, top surface. What is the flux through the top surface? Area vector is like this. Area vector is perpendicular. What is theta? 90. So flux will be E ds cos 90. Cos 90 is 0. Correct. What is the flux through this surface? Again, area vector is towards you. Field is in this direction. Angle is 90. 0. What is the area vector here? Area vector is downwards. To the right, field theta is 90. Flux is 0. And for this surface, area vector is towards me. Right. So flux is 0. So my point is the top surface doesn't have any flux. Right. Front surface doesn't have any flux. Bottom surface doesn't have any flux. And back surface doesn't have any flux either. That is actually common sense. I'll tell you why. Because, so flux is there only for the left surface and right surface. It's common sense. Just imagine a river is flowing. A river is flowing. River is flowing from left to right. Why should I say left to right? Because electric field is only along x-axis. Electric field is my river. Electric field is my river. Okay. Electric field is my river. All right. And the river is flowing in x direction only. So what do you say about this? The flux, you know, the flow, is there flow in the upward direction? No. Is there flow in the downward direction? No. Is there flow towards us? No. Is there a flow into the board? No. The flow is from left to right, which means only the left surface and right surface are involved in the process. Am I correct? Ah, yes. Only the left surface and right surface. Did you understand? Anybody has questions here? Now, one thing is certain. Flux is there only for the left surface and right surface. So, I am doing left surface first. Phi L, flux on the left surface. What is the equation for flux? E dot ds, right? E dot ds, right? That is E ds cos 180 for the left surface. Why did I say 180 here? Why did I say 180? Because as you can see, for the left surface, area vector is to the left. Area vector is to the left. Left surface, look at that. Left surface area vector is to the left. Where is the electric field? Electric field is to the right. Electric field is to the right. So my point is, electric field is to the right here. Area vector is to the left. So they make an angle of 180. One is to the left, the other is to the right, means they are anti-parallel. So it is 180, cos 180. Cos 180 is -1. So that makes it minus EDS. Minus EDS. Okay. That is minus E is what? E is written there. Alpha x raised to half, right? Oh, alpha x raised to x, alpha, is there raised to half for alpha also? No, alpha x raised to half into what is ds? What is ds? Area of the square plate. Left plate is a square, right? Left plate is a square, right? What is area of it? Area of square is one side square. 0.1 square. It's a square plate. Repeating that part one more time. You've been asked to find the flux on the left side. Flux on the left side is what? E dot ds. E ds cos theta. E ds cos 180. Why 180? As you can see, ds is to the left. E is to the right. They make an angle of 180. So cos 180 is -1. So it is minus E into ds. What is minus? What is minus? E is what? Alpha x raised to half. ds is area. Area means the shaded area. The shaded area. Look at this, the shaded area here, no? Shaded area is actually a square. Shaded area is a square. Square is 0.1 square. Side square, side square. So I put the value. What is alpha? Minus 800 into 800 into what is Ex? X is its location. Where is the left plate located? Where is the left plate located? Can someone tell me? Where is the left plate located? Left surface located? 0.1. Tell me please, I'm asking everyone. I want all of you to respond. Tell me, where is the left plate located? Yeah, tell me the location. Tell me the location. It is at a distance of 0.1. X value is 0.1. Am I correct? X value is 0.1. Do you understand? Oh, okay. So alpha value is what? Electric field is alpha x raised to half. Electric field is alpha x raised to half. I put the value of alpha 800. What is x value? This location is where? At a distance of 0.1. So 0.1 raised to half into, this is 0.1 square again. Oh, 0.1 square, I can simplify if you want. If I want, 0.1 square is 0.01. So that is equal to minus 800 into 0.01. 800 into 0.01, 2 places down, that will be 8 into, how do you take 0.1 raised to half? I'll tell you an easy way out. If you want to take 0.1 raised to half, look at this. This is an age-old technique, 0.1 raised to half. How do we take it? 0.1 raised to half. You have to write it as 10 into 10 power minus 2 raised to half. It's not easy to take 0.1 raised to half, okay? It's not that easy to take 0.1 raised to half. So instead, you better write it as 10 into 10 power minus 2 raised to half. Then what? What is square root of 10? 3.14. Why? Ask me why. Pi square is 10. Have you heard about it? Pi square? Pi square value is actually 9.85. Have you seen this? Not yet. I told you many times in first year classes. Pi square value, whenever you see pi square, you can take it as roughly 10. Understood? Or when you see root of 10, if you want to take root of 10, it is roughly, root of 10 is roughly pi value, 3.14. Understood? So 10 raised to half is, raised to half means root, 3.14 into 10 power minus 2 raised to half is 10 power minus 1. So that is 0.314. I got that value, 0.314. So when you multiply, I'll multiply this 8 into 0.314. Okay, just give me a second. 8 into 0.314 is 2.52 minus 2.52 Newton per Coulomb into meter square. This is 5 left. Did you understand this much? Okay, so let us go to the right now. So we have calculated flux on the left side. You're going to calculate flux on the right side now. What is flux on the right side? This is flux on the left side that we have done. Now flux on the right side. What is flux on the right side? I would say it is EDS cos 0. I am wiping this off for the moment, okay? EDS cos 0, I don't have space there. EDS cos 0. Because why is it 0? Ah, yes, that's right. Why is it 0? Because as you can see, the area vector is to the right. For the right surface, area vector is to the right. Where is electric field? Electric field is also to the right, electric field. Look at that. The direction is same. Directions are the same, no? Electric field is to the right. Area vector is to the right. That makes angle 0. Theta is equal to 0. Same direction. So EDS cos 0. That is E into DS. You have to be very careful here, okay? I don't have space here. Okay, anyway, I'm writing it here, EDS. What is E's value? Alpha x raised to half. Alpha x raised to half. Electric field is alpha x raised to half. Just the way you wrote here, alpha x raised to half. DS is 0.1 square. So let us put the value. That is 800 into. Here you got to be extra careful. 800. I am writing the values here. Look at this. 800 into x. Where is the second surface located? Where is second surface located? Second surface. I am talking about second surface now. Where is it located? 0.2. Yes, good, Arnav, that's right. Yes, this is 0.1 plus 0.1. Am I correct? Second surface location is 0.1 plus 0.1. First surface is 0.1. Second surface is at 0.1 plus 0.1. Why 0.1 plus 0.1? This much is 0.1. Left surface is at 0.1 plus 1.1 for this side. So that makes it 0.2. Yes. So I have to take 0.2 raised to half here into 0.1 square is what? 0.01. And like we did, we will multiply first and last term, 800 and 0.01, that is 8 into. I need to take 0.2 raised to half. How do we take 0.2 raised to half? 0.2 raised to half, just the way you did here. It is 20 into 10 power minus 2 raised to half. Okay, 20 into 10 power minus 2 raised to half. Oh, can you see that? Anyway. This is like, I would say square root of 20 is 4.4. Why? Random value. Because square root of 16 is 4. Square root of 25 is 5. So it should be in between 4 and 5. I'm just approximating. Anyway, you can calculate precisely if you want. Square root of 16 is what? 4. Square root of 25 is what? 5. So this is actually 20. Its square root should be in between 4 and 5. I'm randomly taking it as 4.4 into 10 power minus 2 square root is what? 10 power minus 1. So one place down it is 0.44. I can put it here 0.44. So when you multiply, it is like 3.52 when you multiply Newton per Coulomb into meter square. This is actually 5 right. 5 right. 5 right. Did you understand this? So having obtained the fluxes on the left hand side and right hand side, you can find flux net now. Flux net. Phi net is equal to phi left plus phi right. So what is the total flux now? Phi left is minus 2.52 plus phi right is 3.52. And that is 1 Newton per Coulomb into meter square. In textbook, they got like 1.05 or something. They have calculated it precisely. Okay, 1.05 or 1.03. I don't remember. Anyway, you're not expected to be that precise. I have approximated a lot here. Like I've taken 10 square root as 3.14 and here 20 square root as 4.4. So anyway, it's up to you. In textbook, they have got 1.03 or something. Anyway, 3% error is not a problem. It is 1 Newton per coulomb meter square. That is our first question. Now, second question is to calculate the total charge. That is first question. Second question is to find the total charge. How do you find the total charge? You can apply Gauss theorem. Q by epsilon 0 now. Cross multiply. Q will be what? If you want to find the total charge, it is phi epsilon 0. Phi epsilon 0. That is 1 into, phi value is 1. 8.85 into 10 power minus 12. So that is 8.85 into 10 power minus 12. In textbook, they have got it like 9 or something. 9. So 8.85 won't be a problem. Coulomb. That will be the answer to the second question. Did you understand this? You know, phi is equal to Q by epsilon 0. This is what Gauss's theorem states. So if you cross multiply, Q will be equal to phi times epsilon 0. Phi is 1 Newton per coulomb meter square. You got it. Epsilon 0 is 8.85 to 10 power minus 12. So when you multiply, you're going to get 8.85 into 10 power minus 12 coulomb. Did you understand? This is supposed to be the most important question in first book of NCERT. First NCERT book, and it's been asked many times in board examinations. It's a 3-mark question. Did you understand? Now, before moving to the next question, I'll tell you something.